Welcome back. This is the second lesson recording for IM2. It's February 11th, 2021. Okay, let's bring up a notch on solving quadratic equations. So what if the equation is not factored? Okay, so when you have x squared minus 5x plus 4 is equal to 0. Remember, when it was in the factored form, we could solve very easily. Okay, so if the expression is equal to 0, so we could potentially use zero product property. So if you don't have factors, you need to factor. So with that, you're going to be working on card number 17, 7 to 14 of the Desmos, and then 15 to 16. So card number 7, it says more solving. To solve x squared plus 8x plus 15 is equal to 0, what should be the first step? Hopefully you're saying that we need to factor this expression so that we can use zero product property. Now, what is the missing step? Nileshi is solving the equation x squared minus 10x plus 21 is equal to 0 and found the solution to be x is equal to 3 and x is equal to 7. Okay, do you follow what she did? Fill in the step that is covered under. Okay, what was the step here? Well, she needed to factor, didn't she? Okay, so how do we factor? Well, first thing you should notice is that the number or the leading coefficient in front of the number in front of x squared is 1. So that means this is our simple factoring. So I can put my template and put x here and x here, and the rest is equal to 0. Okay, so now we just need to factor the quadratic expression. I'm looking for two numbers that multiply to positive 21 but that add to negative 10. Okay, what are the factors of positive 21? It could be 1 and 21 or 3 and 7. If I add 1 and 21, that's going to be 22. That's not going to be anything close to negative 10. If I add 3 and 7, 3 and 7 is 10. But so I have 10, but I actually want negative 10. So it's not 3 and 7, but it's negative 3 and negative 7, because when I multiply negative 3 times negative 7, it is going to be positive 21. But when I add negative 3 with negative 7, it's going to get me negative 10. So that is my missing line. Okay, so the next card walks you through the whole factoring and the steps. So if you are trying to solve this quadratic equation, you need to first factor. It gives you all the steps. So first I need to factor. How do I factor? Again, the x squared, the leading coefficient, the number in front of x squared, or a value in this case, is 1. So I start by putting my two parentheses is equal to 0, and I put x here and I put x here. And then so I'm looking for two numbers that multiply to negative 15 but that add to 2. So I'm looking for two numbers that multiply to negative 15. That means I know one's going to be positive, one's going to be negative, or negative positive. What are my two numbers that will add to positive 2? Well, since I'm adding two numbers with opposite sign, I'm looking for the difference to be 2. Okay, the difference of the two numbers has to be 2. What are those two factors? Well, 1 and 15, certainly the difference is 14, so that's not going to work. But 3 and 5, the difference between the two numbers, if I subtract 5 minus 3, that's going to be 2. So that is my combination. Now, which is going to be positive, which is going to be negative? I want the final sum to be positive 2. Okay, so that means I need the bigger number of the two to be positive. So the smaller number has to be negative. So you have x minus 3, x plus 5 is equal to 0. Now we set each of the factors to 0. So we put x minus 3 is equal to 0 and x plus 5 is equal to 0. Then from here I add 3 to both sides, of the equal sign, and that leaves me with x is equal to 3. Actually here, that's my answer here. And then subtract 5 from both sides, and I get x is equal to negative 5. Okay, you're going to keep going. Again, the leading coefficient is 1, so this is our simple factoring. X squared, so we're looking for two numbers that multiply to negative 18 but that add to negative 3. So negative 18 could be made by, so I want the product to be negative 18. That means one's going to be positive, one's going to be negative, negative or positive. That means we're looking for the difference between the two numbers to be negative 3. Okay, so difference is going to be, or difference is going to be 3, and the final sum is going to be 3, negative 3. Okay, so then what are the factors? Well, 18, it could be 3 times 6. 3 times 6 could be have the difference of 6, or 2 and 9, but 2 and 9 has the difference of 7, or difference of 3. So this is 3 and 6. 3 and 6 will be my two numbers. I know one's going to be positive, one's going to be negative. I want the final sum to be negative 3. That means I need the bigger number to be negative, smaller number to be positive. So you can multiply this out using FOIL to just quickly check, does it work? 3x minus 6x is going to be negative 3x. That's the middle term. Okay, then you set each of the factors to be 0. Okay, so then from here, I can bring this plus 3 to the other side by making it into negative 3. So that becomes x is equal to negative 3, and bring the negative 6 to the other side by making it positive version of it. So you're going to add 6 to both sides, and you get x is equal to positive 6. So x is equal to negative 3, or x is equal to 6. What about this? Okay, 2x squared plus 6x is equal to 0. Oh, we only have two terms. Okay, that means every time you look for GCF, 2 and 6, I can take 2 out. What about x squared and x? I can take x out. That leaves me with 2x squared times 2x times what is 2x squared? That's going to be x. 2x times what is 6x? That's going to be positive 3. So I have just factored it. That means the first factor is just 2x. 2x is equal to 0, or x plus 3 is also equal to 0. So then dividing both sides by 2, and this leaves me with x is equal to 0, or subtracting 3 from both sides, and that leaves me with x is equal to negative 3. So these are my two solutions, x is equal to 0 or x is equal to negative 3. Okay, so now we come to a more complicated factoring. Again, we need to factor this in order to find our solutions. Okay, so you have learned the area model or grouping method, right? Now that you're becoming more fluent at it, I am going to reintroduce you the guess and check method, because in some ways it is much easier. Okay, it is much easier. Just the way you created the template, you would create a template for the x's. Okay, now we want to get 5x squared. How can I get 5x squared as the multiplying of the two binomial? One has to be 5x, the other has to be x, because 5x times x is going to be 5x squared. Okay, now we're looking for the number to fill in here. Okay, so it's the same thing. We're looking for the number that multiplies to 18. But you need to be multiplying this out using FOIL. Hopefully by now you're quite familiar with foiling, so that you are more ready to tackle this guess and check method. Okay, so what are the factors of 18? It could be 1 and 18, or it could be 2 and 9, or 3 and 6. So we are going to plug in different values and see what will work. If I put in 1 and 18, that will be 1x times 18 times 5. That's going to be huge. That's going to be way bigger than 19, negative 19. Okay, so we don't want that. Okay, 2 and 9. Or if I reverse the 18 here and 1 here, 18 plus 5 is going to be 23. So that does not work whether I try 1, 8 or 18 and 1. It does not work. So I erase that and then I look at for the next combination. Okay, try 2 and 9. Okay, I know that they either have to be positive, positive, or negative, negative, and since I want the sum to be negative, I know that this has to be both negative. So, oops, let me try that again. So we have 5x and we have just tried 1 and 18 and we knew that that didn't work. So now we're going to try 2 and 9. Okay, so but we also know that they both have to be negative, negative, because the only way I can get positive 18 as the multiplying of the two and getting the negative 19 as the sum is if they are both negative. This is something that you should have recognized when you are factoring with the when leading coefficient is 1. Okay, so now we're going to try 2 and 9 and see if it works. If I put 2 and 9 here, that means I have negative 2x minus 5 times 9 is negative 45. That's negative 49x. That's way too big. That's not going to work. Okay, so then I erase this. And this time I am going to try 9 and 2. Okay, 9x is negative 9. And this is going to be negative 10x. Negative 9x plus negative 10x indeed is negative 19x. And so I have just factored it. Okay, this method, you do not need to go to diamond. You do not need to go to grouping. You do not need to go to area model. However, if you find that this method is too complicated for you, yes, by all means, go back to the grouping method or area model. But if you're doing that, you do need to do diamond. Okay, there is no other way to do it. And certainly there are variations of doing the diamond by creating a t-chart and so on, but you're essentially doing the same thing. Now that I've factored, I can set each of the factors to be 0. So 5x minus 9 is equal to 0, or x minus 2 is equal to 0. So I add 9 to both sides. So that gets me 5x is equal to 9. Divide both sides by 5. And I get x is equal to 9 over 5 on the one hand side. Or x, you add 2 to both sides, and that leaves me with x is equal to positive 2. So I have two solutions, x is equal to 2, x is equal to 9 over 2. Okay, I'm going to keep showing you the guess and check method. Okay, so here we go. So the only way I can get 8x squared, I actually have two different combinations. Okay, it could be, I could have 8x here and the x here. The other possibility is indeed 4x times 2x. Okay, so these are my two possibilities. Let's start with the top one. Okay, or let's start with the bottom. It doesn't really matter. I mean, you have both. As you get better at it, you're going to start to sort of see some patterns and you're going to be able to eliminate things. All right, so I am looking to what are the factors of 27. That could be 1 and 27 or 3 and 9. Let me try 3 and 9 with this. If I put 3 and 9, and I know that they're positive, but they're multiplied to positive, add to, so it's going to be negative, negative here. And then I try different combinations.